The ages of 23 applicants who were unsuccessful in winning promotion have a mean of 47 and a population standard deviation of 7.2. Assume that the sample is a simple random sample and find a 95% confidence interval for the average age. So this problem is asking us to build a 95% confidence interval for an average. So in this case, the formula is going to be x bar minus e to x bar plus e. Or you can use, so this is the interval notation, or you can use x bar minus e is less than mu is less than x bar plus an e. So this is a inequality notation. E is the margin of error, and the margin of error is going to depend on whether you're given the population standard deviation or if you're given the sample standard deviation. So if you're given the population standard deviation sigma, then that means that you're going to use a z distribution or the standard normal distribution. And if you're not given the population standard deviation, in other words, if you're given the sample standard deviation, you're going to use a t distribution. So in this case, the problem is telling us that the population standard deviation is 7.2. Because it has this word population and then population, that means that the standard deviation given to us is sigma. So because sigma is given to us, then we're going to use z sub alpha over 2 in our formula. So it's E equals z sub alpha over 2 times the square root of sigma squared over n. And then what we want to do is we want to go and extract the information based on the symbols that we're going to need. So we're going to need sigma squared or sigma. For the margin of error, we're going to need n, which is a sample size. We're going to need z sub alpha over 2. And then for the actual confidence interval, we're going to need x bar, which is the mean. So sigma is equal to the population standard deviation, and our problem said that the population standard deviation is 7.2. That means that sigma is equal to 7.2. So had the problem said that the information has a mean of 47 and a population variance of 7.2, for example, then instead of writing sigma, you would write sigma squared equals 7.2. So here we're given the population standard deviation, that means sigma equals 7.2. If you were given a problem that said that these people had a mean of 47 and a standard deviation of 7.2, so basically without the word population, that would mean that it's giving you the sample standard deviation. So instead of sigma, you would write s. Instead of sigma squared in the margin of error formula, you would write s squared. And instead of that z sub alpha over 2, you would be writing t sub alpha over 2. So again, here we're given population, standard deviation, so we use sigma. Then we also need n, so n is a sample size. The sample size is a number of applicants. There's 23 applicants, so n equals 23. We're also going to need z sub alpha over 2, but we're going to wait on this. We're going to need x bar, so x bar is the mean. So the sample mean is equal to 47. We're also going to need z sub alpha over 2. And for z sub alpha over 2, we can do it in one of two ways. We can find it in one of two ways. We can either use a common critical values table, or we can use the actual z distribution table, so the standard normal distribution table. If you wanted to use a common critical values table, we would go to the common critical values, and in this case, we know that alpha is equal to 0.05 if the confidence is 95%. So confidence of 95%, subtract off, or take 100 minus 95%, that gives you 5%, and change that 5% into a decimal, and that gives you that 0.05. You can also see it here. So 95% gives you alpha of 0.05, and the critical value is 1.96. So z sub alpha over 2 is 1.96. So again, that's one way to go and find it. The other way to find this critical value is by using the table. So first, let's go ahead and draw a picture. And if we draw a picture for the normal distribution, it's going to be bell-shaped. And because it's a confidence interval, we're going to draw two sides to this. So the middle area is going to be the confidence, that's 95%. And the outside in total is going to be 5%. So if the middle is 95%, the outside is going to be 5%. And that's because the total would be 100%. The middle is 95, and 100 minus 95% gives me 5%. Change that into a decimal and you get alpha. So alpha equals 0.05. One area, one of these pieces on the outside is at alpha divided by 2. So alpha divided by 2 is equal to 0.05 divided by 2, so that gives me 0.025. So because the z distribution is symmetric, that means that this piece on the right side is also going to have an area of 0.025. So now if we look up that 0.025 on the z distribution table, so let's go to the z distribution table. So we said we're going to use 0.025. I would say look up the values. So look up the value 0.025 on the inside of the table, because the inside of the table gives you areas. So if I look up 0.025, if I go down on just the first column, look up the number that's closest to 0.025. So 0.0228 and 0.0287 are pretty close to 0.025. So I'm going to go to 0.028, go to this row, and then go across. That gives me 0.0192, and if I keep going, it's getting smaller, so that's not going to help. So go to the next row, 0.0287, 0281, 0274, 0268, 0262, I'm getting closer, 0.025. So that's the number that I was actually looking for. So 0.025, if I go to the left, is going to give me negative 1.9. If I go up, I get a 6. If I put these two together, I get negative 1.96. So if I go back, this value is negative 1.96. That means that this value on the right side is positive 1.96, which is exactly what we found if I use the common critical values tables here. So all I need for this confidence interval is a positive one. So extract the positive one if you had used the z distribution table. So let's go ahead and use our values and plug them into our formulas. So based on the formula, we needed sigma, we needed sigma, let's see. We needed sigma, we needed sample size, we needed the mean, and we needed z sub alpha over 2. So plug these in. So to find the margin of error, this is equal to z sub alpha over 2 times square root of sigma squared over n, which is equal to 1.96 times the square root of sigma, which is 7.2, squared over n, and n is equal to 23. So then go ahead and calculate this. So we get 1.96 times the square root, so just go to second and then square root, 7.2, and then hit the square button, divided by n is equal to 23, and that gives me back 2.94255 and so on. So then I'm going to use 4 numbers after the decimal, so 2.9426. So in the textbook it would say to use a specific number of decimals. Just go ahead and use 4 numbers after the decimal for the margin of error. for the critical value, just copy it down as you see on the table. So once we find the margin of error, we can go ahead and find confidence interval limits. So x bar minus e, which is equal to 47 minus 2.9426. And then we calculate this, and we also find x bar plus an e, that's 47 plus 2.9426. And if we calculate these, we're going to get 47 minus, and just like we did in the past, we can go ahead and scroll up and hit enter on the value that you want to subtract off, and this gives us back 44.0574. So this is 44.0574. And for the next one, so 47 plus 2.9426, you can go ahead and scroll up to the expression, hit enter, and then go back until you get to the minus sign and replace it with a plus. And then hit enter, and that gives us back 49.9426. When you're doing this on the calculator, of course, you can just type in the 47 minus and the 4 numbers after the decimal, and the 47 plus the 4 numbers after the decimal, or even 47 minus all of this into the calculator, and 47 plus all of this into the calculator. So rewrite this as an actual confidence interval. So the confidence interval can be written in interval notation. So 44.0574 to 49.9426. So this is interval notation, or you can write it as inequality notation. So 44.0574 is less than mu is less than 49.9426. And that would be your inequality notation. So you can interpret this as we are 95% confident that the interval between 44.0574 and 49.9426 contains the population average age of applicants who were unsuccessful in winning promotion. On the test, you would interpret only if the problem is asking you to write an interpretation. Otherwise, your final answer would be left as just one of these two intervals.